This is the video for Markov Link Routines. There are two routines, one on the left and one on the right. We'll start with the one on the left. First does a reset to all probability distributions. Down here it's going to do a peck instruction to get a random value. It also sets SG to the game number, and it uses that down here as a seed for the random number distribution. Next, it fills 36 values at matrix with 0. We're going to be working with a 6x6 matrix, so it's first zeroing out all the values. It's a null matrix at that time. Next, it says for I of 0, and down here, next I 14, 7 at a time. So it's going to be 0, 7, and 14. Now we'll go back to where it started. Here, it's going to be a peck instruction. That means pick equally likely. Well, the equally likely values go from 0 to 30. See, there's 31 of them, but they go from 0 to 30. So when it does this peck instruction, it's going to randomly select one of those values, and it'll put it in random value. Then it adds 20 to the random value. Well, random value went from 0 to 30. Now it's going to go from 20 to 50. Then it divides that random value by 100. So it's going to go from 0.20 to 0.50. Then it sets a value in the matrix at offset 1 plus I to that random value. Well, we know at the beginning I is 0, so this is 1 over from 0. And actually this is going to change with the diagonal, but always be 1 to the right of the diagonal. Then it sets J to 4 plus I, and it says if that's less than 18, go to AC down here. But if it gets greater than 18, then it's going to subtract 6 from it. This is because the very third row we do, adding 4 to this offset is going to put it onto the next row. But we want to keep it back on the third row, so we subtract 6 from it. You see, it went off the end, we subtract 6 back and put it at the beginning. And here we do. It sets matrix at offset J to 1. Then it subtracts from it the random value. That means that on that particular row, there's the random value and there's 1 minus the random value. So that row adds up to 1. Then it does another peck. This time it's going to get another number from 0 to 30. It's going to add 20 to it, so it's going to go from 20 to 50. It's going to divide it by 100 again, so it's going to go from 0.20 to 0.50. And then it says at matrix 19 plus I, well, up here it was 1. 19 is 3 rows down from there over 1. So again, it's 1 over from the diagonal. And it puts the random value, it puts the random value at that position. Then it says at J22 plus I. Well, that's 18 more again. That's down 3 more rows. Then it checks to see if that one went off the edge. Did it go off the end of that row? If it's less than 36, it's okay. That means 35 would be all right. But if it's not, it subtracts 6 from it. So if it goes off the end of the row, it puts it back to the beginning of the row. And here it does. It says, put that value to 1 and subtract the random value from it. So now we have the bottom 3 rows of our matrix also add up to 1. And here we have the next I that went around 3 times, but it did things to the top 3 rows and then the bottom 3 rows. Well, after it's through there, it moves the 36 values that we just made in matrix and moves them to a list called steady state. Then it sets LS to 6. Now L is used for the offset between rows. Well, our rows are all 6 long, so that offset 6 just means we're just going 6 to get to the next row. But the next one, set NS control register to 1006, says that it's a square matrix. You don't have to tell me how many rows and columns, just the N value we need says that it's 6 by 6. The 1000 tells it it's a square matrix. Then it says for I of 1 to 8, one at a time. Well, it'll go around here 8 times. Each time it's going to take the steady state that it knows, moves it to whole matrix, multiplies whole matrix times whole matrix, gets another steady state, goes around the loop again. So it squares it, then it takes it to the 4th power, the 8th power. By the time it gets done with the 8 times around, it's the 256th power. Then, so that's the power of 256, but then it's going to multiply matrix times that steady state to give steady state at offset 40. It's going to raise it to the 257th power and store it at steady state plus 40. Then it's going to take that 257th power, multiply it by matrix, and get the 258th power of the matrix, and store that at steady state plus 80. That's the end of the first routine. Here's the second routine. First, it's just setting an XY position to 664. That's more than halfway over. Sets a font, sets a color to a dark red, and puts the text on the screen steady state. Then it starts to make a rectangle here. It's telling how tall it is, 100, how wide it is, 400, and where its position is. It says it's at X 480, Y 70. Then it sets this index it's going to use for the color to 0. Then it says for L of 0, and down here it says L is going to change by 40 till it gets to 80. So it'll be 0, 40, and 80. Remember that's where our 3 steady states are at offset 0, 40, and 80. The first thing it does is it sets the color to one of its colors, and the colors are red, green, and blue. And then it does a rectangle fill. To this XY position that we go, and this tall and that wide. Then it sets the font to 412, the color to black, and then it puts the information needed for this box N instruction. It needs to know if there's going to be many values in this list that are to be displayed. It needs to know what's the offset between rows. It says 6. What's the number of rows? It says 6. The number of columns is 6. It's a square matrix. Then it adds a little to X and Y because we made a rectangle up here, but we want to move over and down where we want to put these values in that rectangle. Then here it boxes them, and what it's saying here is there's 7 positions in the number, and the 123,000 added to it told it it needs to know the offsets and the number of rows and columns. This 0 indicates that it's not clickable, it's not updatable, and it's going to show the steady state at offset L, first 0, then 40, and then 80, the ones we made over here on the left. Then each time it does that, it's going to adjust X and Y back again, but it's going to add more to Y because it's dropping down to the next rectangle. Alright, and that's the end of it there. Well, we could take a look at it from over here, and here is the original transition matrix that we made. Over here are the 3 steady state ones that we just displayed, and we notice that, well, in the steady state, the columns are also all supposed to have the same value in them. Well, there's some zeros in it. Well, that's because when it comes to this power, this is what it looks like. The next power, it looks like this. The next power looks like this. Then it goes back again and keeps repeating this. That's why it says it's a link. It's like links in a chain, and there's a red link, a green link, then a blue link, then a red and a green and a blue, on and on and on. They're going to have those zeros in there. Well, these are the 3 steady states for the Markov link. And this is the end of the video on Markov Link Routines.